Welcome to the Air Preparation module of the IMI training tool. In this module, we will discover why air preparation is so important and the processes involved. We'll introduce some of the most popular products in the Norgren range that perform the task so well. From here, you will get the chance to dig deeper in the intermediate course. Compressed air is often referred to as hot, wet, and dirty. Without the proper processes, this resource can cause significant damage to a compressed air system and attached components, and ultimately cost money or even endanger lives. It's crucial that we prepare air properly to prevent damage and maximize the length of use for all components in a system. The process of preparing the air involves filtering, regulating, and lubricating the air, often referred to as FRL. This module will explain how this process works and why it is so important. The first, and in many cases the most important stage of the air preparation process is filtering or cleaning the air. All systems can benefit from filters, and they come in many forms. Norgren offers filters from mini 1/8 of an inch to big 2-inch units as general-purpose filters, coalescers, or oil vapor removal filters. Water represents over 80% of all contamination within compressed air. Wet air causes corrosion through the entire system and reduces the lifespan of components. Fragments of corroded piping can end up being fired through the system and cause significant damage. Adding a dryer to an existing system that is already suffering from corrosion can actually exacerbate this problem, causing more fragments to become loose in the system. A dryer reduces the pressure dew point, or PDP, of the air. The PDP is the temperature at which condensation will start to occur. It's the point at which the air can no longer hold all the moisture within it. If a dryer reduces the PDP to -40 degrees Celsius or -40 degrees Fahrenheit, then it would have to fall to below that temperature for any remaining moisture in the air to condense to liquid. So there are two important temperatures to be aware of in and around a compressed air system: the atmospheric temperature and the temperature at which water will start to condense in the system. As well as removing water, we need to remove unwanted oil, usually from the compressor. This contamination can cause issues itself, but when mixed with moisture, it creates a substance that isn't good for lubrication and can stick to moving parts inside pneumatic components, slowing cylinders, for example. But why do we add oil if we have already gone to the effort of removing it? Later, we'll talk about adding oil to a system with a lubricator. This clean, controlled oil ensures smooth running of components and is very different to the dirty, unpredictable oil from a compressor that may be circulating through a system. Filters also allow us to remove dust, particles, and fumes. Filtering air obviously costs money, but every application will benefit. The correct filter with the proper maintenance will pay for itself through increased production efficiency. Filtering air is nearly always best at the point of use, but has benefits throughout the system. Filters at the point of use can remove any contaminants that enter the system after they have left the air receiver. For example, changing air temperature may cause moisture on the way to the point of use. With all this in mind, let's take a look at the range of filters available to us and how they work. Here are 3 filters: a general-purpose filter, a coalescing filter, and an oil vapor removal filter. The level at which you clean the air is dependent on the application, and the level of spend needs to be justified based on the reduced maintenance costs. A general-purpose filter can be used to reduce the levels of water, dust, and particles in compressed air. In particularly contaminated areas, they can be daisy-chained to increase effectiveness. Let's see how it works. The air enters the inlet port on the left before it hits the solid wall and is directed downwards. Any very large particles or water droplets will lose their momentum as they hit the wall and fall into the bowl below. As the air continues to move into the filter, it moves across the angled fins of the louvre, causing a cyclone effect. Momentum forces smaller water droplets to the outside of the bowl, and gravity causes them to collect at the bottom. While the air is very turbulent above it, the baffle creates a quiet zone below it, where the air isn't spinning. This is so the water and particles that have collected here don't re-energize back into the air route. The water that does collect needs to be drained periodically. If the level reaches above the baffle, water will re-enter the airflow. We've used a manual drain in most of our animations to demonstrate the process more clearly, but remember, always lead with an auto drain. We'll cover the reasons later. The air is now directed through the depth filter element that not only stops particles, but long strands too. Filter elements are rated on their micron size. This is the size of particle it will stop. The two options that Norgren offer are 40 micron and 5 micron, with 40 being the standard and typically used for actuators. 5 micron is usually specified to protect more sensitive parts, like a proportional valve. Now the filtered air leaves through the outlet to carry on downstream. Norgren's Pure Air coalescing filter removes oil and extremely small particles down to 0.01 micron from compressed air. It works by forcing air through an element where it changes direction and bumps into itself, causing any oil to coalesce or stick together, creating bigger drops on an outer sock. As it gathers, it gains mass, and so gravity forces it downward into the bowl. When it's working, you will notice a wet band around the sock as the oil gathers and drains into the bowl. Contaminant oil needs to be drained before it reaches the bottom of the element, or it will be pulled back into the system. Check for replacement intervals and operating limitations regarding temperature. An oil vapor removal filter uses activated carbon to extract oil vapor and odors from air. In a similar way to the coalescing filter, air is forced through an element, but this time the element is made of activated carbon that captures the oil particles at a molecular level. Once through the carbon, the air passes through a dust retention layer before exiting. There is no drain required, as no liquid will collect. If the filter is exposed to liquid oil, it will no longer function and will need to be replaced. The carbon pack contains dye crystals that turn blue if exposed to these contaminants. If activated, it's important to understand the source of the problem. This element needs replacing rather than servicing. Check for replacement intervals and operating limitations regarding temperature. The elements used within any of these filters will have a classification code relating to their suitability and micron rating. You can see that the Norgren F84G general purpose filter, for example, has two classifications, one for particles and one for water. Coalescing or oil vapor removal filters would also have two classifications, one for particles and one for oil. Remember, a lack of servicing can lead to a loss of pressure and inefficiencies in the system. Although many customers don't realize, all filters need maintenance, with a general purpose filter needing a service every 12 months. Proper servicing ensures efficient running and longer life. In fact, some filters just won't work if they haven't been serviced or replaced when required. With planning, it doesn't have to be disruptive. It's advisable to service parts when machines are on planned maintenance. Although we have already mentioned them, there are a few important considerations when selecting the bowl. Norgren has 3 types. Polycarbonate bowls can be produced to local standards, but all meet British standards and are very safe if used properly. Both bulletproof screens and crash helmets are made with polycarbonate, so it can be incredibly strong. On smaller units, polycarbonate is the standard option. It's a very practical and cost-effective option, with fluid levels inside easily visible. It does have its limitations, though, and can't be exposed to solvents either internally or externally. In some situations, it will need to be fitted with a guard. This is a condition of the British standard and a minimum requirement in some countries. These guarded transparent bowls are standard on some products, including Exelon Plus. Remember though, even with the guard, all the polycarbonate rules and regulations still apply. Some units will require metal bowls because of the increased pressure they are likely to contain. Metal is more suited to some aggressive atmospheres and the only option when dealing with solvents. The final important element of these filters are the drains. The contaminants that build up in the bowls need to be evacuated, and Norgren standardize on 2 main types of drain to achieve this: manual and automatic. Automatic is usually the best option. It means the filter can be left without constant monitoring, even with changing operating conditions and environments or seasonal changes. Although manual drains are cheaper to buy, they may not be a more cost-effective solution, as operators will need to remember to check bowls, especially if something changes upstream, for example. This time clearly costs money, but if something is missed, it could cause more serious issues. The next stage in air preparation we'll learn about is pressure regulation. In many cases, a compressor will cut in and out as it fills an air receiver to the required pressure. This means that the pressure in the system may not be constant, which in itself can cause issues. In the first instance, a regulator smooths this problem and ensures a regular pressure at the point of use. Reducing pressure to the minimum required level will also make the system safer and reduce costs. A regulator also adds additional safety to a system. When using flexible piping, a loose pipe can cause damage and serious injury. A regulator reduces the pressure in the system to the operating minimum, mitigating the risks of loose pipes. Too much pressure in a system is wasted energy. Lower energy systems are inherently safer. An accident at 20 psi is likely to be less dangerous than one at 100 psi. A regulator can also save a lot of money. Just a 1 bar drop in pressure can reduce running costs by up to 7% across an entire compressed air system and the components that run on it. Also, tools have a pressure rating for optimum efficiency. More pressure doesn't mean more performance and can in fact reduce the lifespan of the tool. A regulator will provide the optimum amount of pressure for individual tools. Regulators are essential on most systems and can quickly pay for themselves. Norgren offer a number of pressure regulators. Remember, these don't regulate flow, but we do offer products that will. Norgren flow regulators. This is a general-purpose regulator. As the chamber under the diaphragm is currently at atmospheric pressure, the diaphragm pushes down on the valve pin, which is connected to the valve seat, so the valve seat drops. This allows air from the inlet port, P1 in graphic, to go downstream and exit through the outlet port. As the air passes through P2, some of it passes up through a breather hole into a compartment below the diaphragm, causing the pressure in this chamber to rise. As the pressure in the chamber grows, it mitigates the effect of the large spring above and allows the smaller spring underneath the valve seat to close the valve. Now, the force on the top of the diaphragm due to the spring is equal to the force on the bottom of the diaphragm due to the air pressure. When a demand is put on downstream, it creates a pressure drop, so the pressure in the chamber below the diaphragm decreases, allowing the valve pin to drop and more air to flow. This process repeats continuously as the diaphragm moves up and down, opening and closing the valve in an attempt to stay in balance and maintain pressure as supply and demand change. This example is of a relieving regulator, which is standard. It allows air through the hole in the diaphragm assembly while adjusting the pressure, and relieves when downstream pressure is greater than that at which the regulator is set at. It does not serve as a relief valve, but does allow pressure relief if the pressure is initially set too high and needs to be reduced. The filter regulator is the most popular unit Norgren sell. It combines a filter and a regulator into one compact unit, providing a series of benefits. They save space over having units side by side, save money as the system is cheaper than individual units. They are easier to fit, fewer connections mean less air loss, and perform better as flow characteristics are optimized. The regulator needs to be on top and they need to be installed upright for the bowl to work correctly. So in some applications, they may not be suitable, and separate products will need to be installed. Lubricators introduce the correct amount of lubricating oil into a system to reduce wear on pneumatic equipment. Most Norgren products will work without lubrication, and a non-lubricated system is cleaner. However, lubrication can increase the life of valves and cylinders by up to 4 times. If you choose to lubricate your system, the oil that's introduced will remove the grease that was added when the units in the system were assembled. That means lubrication cannot be removed at a later date. Norgren have 2 types of lubricator. an oil fog lubricator, and a micro fog lubricator. An oil fog lubricator can be identified by the green drip rate adjuster on the top, and similar systems are available from many manufacturers. Flowing air creates a pressure variance that sucks oil from a reservoir up a siphon tube before it is dropped into the sight dome, breaking into smaller droplets which are caught in the air and carried downstream. A flow sensor ensures proportionate delivery, and drip rate is adjusted with the control on the sight dome. Each unit has a start point, which is the minimum flow of air required to begin the process. This approach is best used when air is traveling short distances with a high demand for oil, where pipes are level or downward. The oil doesn't travel very far because of its size and momentum. It works well with bigger actuators or air motors. The micro fog lubricator is a Norgren innovation that solves the issues associated with an oil fog lubricator. It's our most popular lubricator, is only available from Norgren, and can be identified by the red drip rate adjuster on top. The micro fog lubricator is easier to adjust and creates a much finer mist that allows the oil to travel further downstream, even uphill. The oil will reach anywhere the air flows. This time, most of the oil that has dripped down from the sight dome goes back into the reservoir. It's only the smallest 10% of particles that get caught in the Venturi effect, sucking them into the outflowing air and downstream. As with a traditional lubricator, a minimum flow rate needs to be achieved to begin the process. Relief valves. A relief valve is able to exhaust air quickly if there is excessive pressure in the downstream system, ensuring the system doesn't exceed a maximum pressure. They protect equipment and personnel if pressure increases unexpectedly. If, for example, a cylinder was pushed back accidentally and a pipe burst, a relief valve is a product that helps with safety. Simply switching air on in a system without controlling the process can cause stress on equipment and eventually failure. A soft start valve controls the introduction of compressed air into a system to mitigate these risks and lessen the chance of those working on the line being startled by a sudden start. The valve slowly increases pressure until the downstream pressure reaches 50%. At that point, the valve will snap open and release the remaining pressure. A dump valve allows the quick release of pressure in the system, usually in emergencies. This powerful evacuation of air would cause very high levels of noise and potentially hearing damage, so it's important to fit silencers on the valves. Sometimes it can be easier to order the complete solution in one box. Norgren offer box sets that include a shut-off valve, filter regulator, lubricator, gauge, and mounting brackets, all fully assembled. This approach means a more cost-effective solution with one part number. It's all designed to work together and ready to install. That's the theory. Now let's take a look at the Norgren product range for air preparation. Exelon is a very popular IMI Norgren product. It's a filter regulator lubricator, or FRL, that is now being replaced by the improved and updated Exelon Plus. Exelon Plus is a modular FRL that is suitable for all industrial applications. A series of innovative new design features make this system stand out, with easier maintenance and an even safer design. It's lighter and more compact, but with no compromise to performance or robustness. A new design of diaphragm means less lag between changes in inflow pressure and the regulator's reaction. It's faster and more accurate, with fewer variations. More details about Exelon Plus are available on the intermediate course. Both Exelon Plus and Exelon Concept can utilize the quick clamp system, allowing quick, easy replacement of units without disturbing pipework. The Norgren Olympian range was released in 1972, an Olympic year, and has proven incredibly popular with millions in operation around the world. The latest iteration is the 64 series, which is still compatible with the original 13 series. Olympian Plus offers a fast, easy method for changing components based around a yoke system. With two industry-leading products for air preparation, how do you choose between them? Obviously, every application will have its own requirements. However, there are some key features to remember. They're very similar. The biggest difference is the modular system on the Olympian Plus. Both can be removed and fitted without disturbing pipework, although Olympian is a little quicker. Exelon is the lower cost. Exelon individual units can be mounted in a number of ways. Exelon requires tools to install and remove units. Olympian does not. Olympian only allows correct installation, avoiding units being installed the wrong way round. Check availability when making your selection. Norgren offer a number of parts that are classed as specials. These are modified or enhanced products that have been released to all customers. A good example of a special product is the tamper-proof R16 preset regulator. The unit shown here is a 30 psi or 2-bar unit, although Norgren offer a number of other options. This item would normally be used with blowguns to ensure the pressure does not exceed 2 bar, which is the recommended maximum working pressure for a blowgun. Norgren products each have a nominal bore size, but are capable of operating with port or pipe sizes that differ. The bore size refers to the internals of the unit. This is the size of pipe it was designed to be used with and will perform most efficiently with. The larger the bore, the higher the flow. This table presents the nominal bore size of each product along with the port sizes it can be supplied with. Products can be specified with different size ports to provide the most convenient solution for clients. An underported unit has a smaller port size than the nominal bore size. That means the unit will be asked to perform at a level below that at which it is capable. That normally means the unit will use less energy and be under less stress. An overported unit has a port size larger than the nominal bore size. That means the internal bore is smaller than the pipes attached, potentially limiting flow and leading to slower running machines. Always check the flow required when choosing the product and port size. Norgren has a formula for creating part numbers. This applies across the new range, but is especially relevant in air preparation products. Let's look at a part number. The first digit represents the type of unit, in this case, a filter. The second digit represents the product range, in this case, Exelon Plus. The third digit gives us the nominal bore size, which, as we mentioned, relates to flow. This is measured in 1/8 of an inch. The fourth digit gives more detail on the function of the unit. In our example, G represents general purpose. The fifth digit represents the port size, which is also measured in 1/8 of an inch. Again, in our example, this is 4. The sixth digit tells us the thread form. G represents ISO G thread. The digits from this point become specific to the unit selected. Details can be found on the option selector of the datasheet. It's best practice to follow the catalog part numbers and change a digit if required by the customer. Don't simply build part numbers from scratch. In our example, the 7th digit represents the option for a pressure drop indicator. The N stands for nothing, meaning no option fitted. Some units offer an option, others don't, and N is default. The 8th digit represents the type of drain selected, A for automatic and Q for quarter turn, more commonly known as manual or M. The 9th digit represents the type of bowl. In our example, it's D, indicating a metal bowl with a sight glass. Not all products offer all options. Check the datasheets for more information. The 10th and final digit gives us the filter size. Our example is 3, which represents a filter size of 40 micron, our standard. Filter regulators generally use the same formula but require 13 digits to cover options relating to both the filter and the regulator. If you require a unit without the yoke, use NN in the 5th and 6th digits. There are a number of accessories available for the Norgren range of air preparation products. These can add significant value for a customer. They include pressure gauges that are required on all regulators and filter regulators to allow them to be set at a determined pressure. Having this measurement allows optimum pressure levels and can save significant cost. Tamper-resistant covers mean that once the optimum pressure is set, operators aren't able to change it for their own benefit and possible detriment to the system or safety. Mounting brackets ensure units are installed correctly and safely, meaning fewer leaks. Shut-off valves allow easier servicing of equipment without affecting the rest of the system, saving time and money. That's the end of the module. You should now have a good understanding of how and why we prepare compressed air and the Norgren products most suitable for different applications. There are other related products available from Norgren not covered in this course. Please visit the site to find out more.